Today we're going to be doing rotate array. Given an integer array nums, rotate the array to the right by k steps where k is a non-negative number. So we have an example here. Let's see how we can go from this to this. So over here we know that the k is 3. And we are essentially shifting the entire array by 3 to the right. So the question is, we want to do this in constant space, so without using any additional data structures. So the question is, how can we shift all the elements by 3 to the right without using any new space? So one thing we can note is that whatever the action that happens, we can sort of group the action by k elements. So over here we took the last k elements and moved them to the start, and the rest of the elements stay the same. So the question is it possible to move these elements to the start without sort of using any additional data structures or going through a bunch of movement operations, like basically swapping 5 with 1 and 1 with 3 or 4 actually. So one way to think about getting these final k elements to the start would be to reverse the entire list. So if you reverse the entire list, we would have this thing. Let me actually remove the spaces. We would have this thing, and now we have the last k elements at the start, but they're not in the right order. So essentially we would need to reverse over here, and if we do that, we would get, if you reverse the first k elements now, we would get 5, 6, 7. So now they're matching up. And if we reverse the last n minus k elements, we would get another match. So it would be 1, 2, 3, 4. So that means we want to reverse the entire list. Reverse first k elements. Reverse last n minus k elements, and that should work. So let's implement this. We can start by making sure k is as small as it needs to be, by making sure we don't have to shift entire arrays worth of elements. So that would be just length of nums modulo k. Because you can imagine, if k was equal to the length of nums, we would just be shifting the entire array until we got it back to the original position. So we don't need to do that. And once we have this, we can reverse the entire array. So that would be nums of everything is equal to nums of everything in reverse. Now we need to reverse the first k elements. So nums of the first k elements would be nums of first. Actually, this would be the opposite. In reverse. And then we reverse the last k elements. There we go. So we reverse all the elements, we reverse the first k, and then we reverse the last n minus k elements. That should work. Let's try it. So it looks like, what's wrong here? Our output. Looks like we're doing the operations here wrong. So the first key element would be this. Okay. That does make sense because K, we're saying first K and then everything else, and then last K and everything at the start. Okay, let's try this. What's going on here? Oh, I see. So the modulus is supposed to be the other way around. We're supposed to say reduce K to reduce a duplicate array sizes within it. There we go. Okay. So let's analyze the space and time complexity. The space complexity here is O of 1. We do not create any additional data structures. The time complexity here is, we can think of reversing everything to be sort of a linear operation because it's just doing swaps until we reach the middle. This is also doing swaps for the first k elements. This is doing swaps for the last n minus k elements. So we have sort of this thing going on, but since we can remove constants here, the time complexity is O of n.